Okay, so, I'm trying to, now that I remember, I'm trying to turn on the YouTube video so that I can, post it for recording, for review, for those of you who need it. While I've got it here, do this. Okay. Well, all right, I'll just. Okay, so any other questions concerning the videos? Because I want to get into the assignment. Let me share my screen. Okay, so for those of us who are here in person, I'm just gonna hand these out right now. Okay, so let me publish the assignment for you guys over here in Zoom. Okay, so here goes. Thank you. Oh, I know this assignment. I gave you guys assignment one already, right?
I was locked.
Yeah, it
Okay.
says it's 2025.
I didn't publish that. No, I thought I needed you guys to. Okay. Assignment two, let me unpublish that. All right, so assignment one is what we're looking at right now. So let me open that up for you guys over there. Zoom. Okay, so you guys out there in Zoom, you should not be able to download it, all right, because I've just published it. All right, so for number one, it's asking a series of questions, testing your understanding of different terms that we would have learned in introducing this discipline, chemistry. So let's see if we can answer these questions collectively. Starting with, because the question is asking, what do you understand by the following terms? All right, so the first term is chemistry. So can anybody tell me, in their own words, what they understand by this particular term? What is chemistry?
The study of all aspects of
The study of what?
all aspects of matter.
Of matter, okay, I would accept that, yeah, study of matter. I would add to that, however, and the changes that they undergo. Well, okay, I think what you did was actually a good comprehensive definition, so I will leave it at that, all right? Okay, so that brings us to B. What is again, according to your understanding, what is matter?
It can occupy space.
Well, that's one part of it. That's one part of the correct answer. Anything that occupies space and has mass, exactly. Anything that has mass and occupies space, or anything that has mass and has volume as well, all right? Okay, so that leads us now to C, the scientific method. What, is your understanding of the scientific method?
A process through observations and experiments that
Okay,
helps define a hypothesis.
okay, so you're trying to go through all the steps. And you could do that, you could say, well, the scientific method involves observation, hypothesis, experimentation, theory, scientific law, but and I wouldn't take out points for that, but what would be a more comprehensive statement that you can use to express what you understand what the scientific method is?
It's the process by which we affirm or deny scientific truths or processes, verified processes.
I guess I could go with that.
It's the process from a question to a theory or law.
Okay, I guess that could work as well. What I was actually looking for is something like a process using, a process used by scientists to understand, investigate and understand nature. Or the natural world, let's put it that way, natural world. All right? But what you said and what you said, I would accept as well. All right, okay, oh, by the way, you guys out there in Zoom, please feel free to participate. So that brings us now to D, observation. Observation, what is your understanding of that term? Of course, you recognize that observation is actually the first part of the scientific method, right? So observation in your words would be,
So natural,
I'm sorry,
a natural phenomenon that can be measured.
natural,
Phenomenon.
oh, natural phenomenon that can be measured. Well, actually, the measurement part of it would be the observation, so I would probably say something like, well, let me just use the expression that I would prefer to use. I would say using our senses to observe, as she just said, a natural phenomenon. Right, so you see it, or you can hear it, or you can, well, I would recommend you taste it. In some cases, you can feel it, like you feel the outside of a testicle if it's cold or hot or something like that, right? Okay, okay, the next one is hypothesis. What do you understand by that term, hypothesis? Again, it's another step in the scientific method.
Excuse me, Professor?
Yes, ma'am.
Where is the assignment posted in Canvas?
Okay, so if you go to files, hold on, let me show you here. If you go to files and then you click on, let me show you what it looks like. You click on, oh, okay, my fault again. I forgot to publish this here. My fault. Okay, so I'm sorry about that. You go here and then you click on chapter 1 and that brings it up.
Okay, thank you.
Okay, so we're at hypothesis, which is another step in the scientific method. So let me hear what you have to say about that. What do you understand by that term?
Tentative explanation,
A tentative explanation of?
the natural world, or a
No, no,
phenomenon,
I'm sorry,
a phenomenon,
well,
an
a
observation.
tentative explanation of what we observe. All right, so basically, we're just coming up with an explanation, which is reasonable, as I said in class, well, as I said in the video. It should be reasonable, nothing, too outlandish, all right? Which explains, what was observed in the observation step. Okay, so the theory, what do you understand by that term? When you're talking about a scientific theory, what does that mean?
Explanation of a law,
Okay, but there's,
well tested,
what's that?
a well tested.
There you go. So basically, it's pretty much a well-tested hypothesis, which basically explains the law, the scientific law. All right? So it's very important that you understand the difference between the hypothesis and the theory. The hypothesis is just basically a tentative, kind of speculative explanation of what is observed, but the theory comes about as a result of the refinement of the hypothesis through repeated experimentation, right? And therefore, the big difference between the hypothesis and the theory is that the theory has a lot of evidence, data, information that supports it, right? Whereas the hypothesis is more speculative. There's no evidence to support it, but it serves a basis for determining what the theory is. Okay, continuing. Scientific law, somebody mentioned it, so can somebody tell me what that term means?
A rule in nature, that's not.
I'm sorry?
A rule in nature, that's not.
Okay, that's a very good, actually, I've never heard that one before, but yeah, that's a very good, way of expressing what a scientific law is, all right? The way I like to express it, that is correct, I would accept that. The way I like to express it is that it's a statement of, what should I put it? A statement of the observation of nature for which there are no exceptions. That's another way of stating it, right? But that's a very good one. Never heard that one before. Okay, the next one is physical property. So what do you understand by that term when we're talking about the physical property of a substance? Well,
Something that can be used to describe a substance that doesn't include any change to the substance itself.
okay, you're partially right. A physical property is basically a property that, when observed, does not involve a change in the composition or structure of the substance, right? The deficiency in your answer is that you said change, but there's a change that can be observed, but it won't be a chemical change. So for example, the fact that ice melts at 0 degrees Celsius, right? That statement is a statement of the physical property. There's a change, but it's not a change in H2O. It's still H2O before and after, all right? So that's basically what a physical property is. It is a property that, when observed, does not involve a change in the composition or structure of a substance, all right? So if you know what a physical property is, then you should be able to tell what a chemical property is. So when you're talking about a chemical property of a substance, what does that mean?
Property that can only be,
I'm sorry?
property that can only be observed, the chemical change.
Exactly. A property that, when observed, involves a chemical change, or in other words, involves a change in the composition or structure of the substance. All right? Okay, continuing. Element. What do you understand by that term? We all know the elements, sodium, carbon, phosphorus, arsenic, these are all elements. So what do you understand by that word, element?
It can't be broken down.
I'm sorry?
It can't be broken down.
There's one important piece missing from that,
Chemical reactions.
by chemical means. It cannot be, an element is a substance that cannot be broken down into anything simpler by chemical means. And I think I made a point in the video that you can actually break down an element, but that would not be a chemical reaction. That would be a nuclear reaction. And for those of you who have to do Chem 2, you're going to meet, there's a chapter in Chem 2 that will cover nuclear reactions, right? But as far as the definition of elements are concerned, an element is a substance that cannot be broken down into anything simpler by chemical means. Okay, and then if you understand what I just said about elements, then you should be able to define what a compound is. A compound is what?
Made of two or more elements that can be broken.
Exactly, it's a substance which is made up of two or more elements that can be broken down into simpler substances by chemical means. All right? Okay, then we get to homogeneous mixtures. What do you understand by that term? When we say a mixture is homogeneous, what do we mean by that?
Mixes together for,
I'm sorry?
it mixes together thoroughly, and no matter what point of the substance you take a sample, you will have the equal amounts.
Okay, equal proportions, yeah, exactly. The way I would word it is that a homogeneous mixture is one that is uniform throughout. Homogeneous mixture is one that is uniform throughout. A homogeneous mixture is one that is uniform throughout. So, what do you think a heterogeneous mixture is?
It is not uniform.
Exactly, a non-uniform mixture or, well, a mixture that is not uniform throughout, right? The opposite of homogeneous. All right. So that's number one. Okay, now number two, I need to get my my USB cord because I don't have it here with me. So that I can do some writing on this. Give me a minute, I'll be right back. Okay, so. So in this case, number two. They gave you some information about the star. It says that the mass of the star is 2.0 times 10 to the 36 kilograms. And it has an average radius of 4.96 times 10 to the 5 kilometers. And it says here to calculate A, the mass of the star in milligrams, all right? So, oh, somebody just said something in chat. Oh, that's a good question. All right. So you're given the mass as being equal to 2.0 times 10 to the 36 kilograms. And you have to convert that into milligrams, all right? Now, I like to do this, step by step. What I would do is identify that the relationship between the kilogram unit and the gram unit is 1 kilogram is equal to 1,000 grams, all right? And also 1,000 milligrams, milligrams is equal to 1 gram, all right? So these are the relationships that we're going to use. And of course, we're going to express these relationships as conversion factors. The first thing I would do is convert from kilograms to grams. And the way I would do that is I would put 1 kilogram down here and 1,000 grams above, right? So that the kilogram units will cancel out. And then the next step would be to go from grams to milligrams. I would put the 1 gram down here, 1,000 milligrams above, so that this unit will cancel with that. And when you work this out, that will be 2.0 times 10 to the 42. And the units here would be milligrams, and that's it. So that's basically how you would do that conversion of kilograms to milligrams, all right? All right, any questions about this one? Any questions? Any questions? Questions? So, is it okay for me to clear this? All right, let me do that. And let me scroll down. Okay, now in this case, it says the volume of the star is, you have to calculate the volume of the star, and it gives you the formula, right? For the volume, for calculating the volume of the star. That is 4/3 times pi times r cubed, right? So, this again, so in this case, the volume is going to be equal to 4/3 times pi, and r is equal to 6.96 times 10 to the 5 kilometers. And all of this will be cubed. So let me do this calculation. I'll work out what's within the parentheses first. So 6.96 times 10 to the 5, and then I'll cube that, and then I'll multiply by pi times 4 divided by 3. And according to my calculation, I got 1.4, and I need to round up to 3 sig feet. So 1.41 times 10 to the 10 kilometers cubed. That's what I got. All right. So that's the volume of the star in kilometers cubed. And then the C part is asking for the density. Now, can anybody tell me what the formula for calculating the density?
Mass divided by volume.
Density is equal to, density is equal to mass over volume. So the question is asking for you to calculate the density of the star in milligrams per kilometers cubed, right? So we already calculated the mass in milligrams. What was the mass again? Not 1 point, I'm sorry. What was 2.0 times 10 to the 42, right? Milligrams. And then we divide that by what we just calculated here for the volume, which is 1.41 times 10 to the 10 kilometers cubed. And let's see what that gives. So 2 times 10 to the 42 divided by 1.41 times 10 to the 10. And according to my calculation, now this I have to round off to 2 sig figs. So this would be 1.4 times 10 to the 32. That's what I got. And the units would be milligrams per kilometers cube. All right? Okay, any questions about this? So you'll notice, right, that, and of course, earlier in the question, it says you need to show your units and you need to round up appropriately, and that's exactly what I did in each of these cases, right? The units have to be a part of the whole process so that you end up with the correct units in the end. All right, yes, ma'am.
The second one,
Hmm.
I got 10 to the 18.
All right, let me do this again. 2 times 10 to the 42 divided by 1.41 times 10 to the 10. I still get,
No, in the second, in B.
oh, B. So 6.96 times 10 to the 5 cube. And then I multiply by pi. Multiply by 4, divide by 3. I got oh, you're right, 1.41 times 10 to the 18. Thank you. So this should be 80, which means I have to also correct down here, because this number is used down here. So I need to do that calculation as well. So let's see what that gives. 2 times 10 to the 42 divided by 1.41 times 10 to the 18. And I got 1.4 times 10 to the 24. So this should be changed to 24. Right? Thank you very much. Okay, any question about this? Any question?
Show fixed calculations, what changed in the
I'm sorry?
answer? What changed in the fixed answer?
What change in the,
The fixed answer,
what do you mean?
how we just read it.
Well, this was, we had a different number here. Right? And because of that, this has to change as well. So that's why we got a different answer there. Right? Okay, any other questions? Any other questions? Any other questions? Okay, so I take it it's okay for me to clear this, right? And scrolling down. Okay, now this is an exercise in testing your understanding of how to round off appropriately for different mathematical operations. So in this case, it says perform the following mathematical operations and express each result to the correct number of sig figs. And importantly, it says in parentheses here, you're to assume that the numbers in bold type are exact. All right, so if you remember what I just discussed about the difference between exact numbers and measured numbers, right? So basically what we're doing is assuming that all the other numbers that are not bold type will be measured numbers, but the bold type numbers will be exact numbers. So let's start off with the first one. Now, what you would normally do in a situation like this is that you perform the operation within the parentheses first, right? Now you'll notice that this is subtraction. And if you recall from the videos, basically when you're subtracting and or adding numbers, you round off your answer to the lowest number of decimal places, right? So you have 2 decimal places here, you have 2 decimal places here. So whatever the result of that subtraction must be expressed to 2 decimal places. So let's see what that gives. 25.27 minus 24.16, and I got 1.11, all right? So this is basically the result of this subtraction here. And because you have 2 decimal places for each of these numbers, this will be expressed to 2 decimal places. So that is correct as far as that's concerned. So now we're going to get to the next stage where we multiply this number by the others, right? And remember, when you're multiplying and or dividing numbers, you round off your answer to the lowest number of significant figures, right? So here we have 4 significant figures. Here we have 5 significant figures. And here we have 3 significant figures, right? So whatever the result that we get here, we have to round off that answer to 3 sig figs, right? So let's do that. So 1.11 times 100.62 times 4.184, and I got 467.30342888, but because I have to round this off to 3 sig figs, the answer is going to be 467, and that's how you get that. All right? Okay, any questions about this? Any questions? Any questions? Any questions? Okay, let me go ahead and clear this. And scroll down. Okay, so based on what we have just discussed in the previous question, how will you tackle this one? B.
Traction.
Okay, so you do what's within the parentheses first, right? So basically, it's going to be 8.925 minus 8.904. Okay, now I got 0.021. And remember now, when we're subtracting, you round off to the lowest number of decimal places, right? So 0.021 is fine because that is expressed to 21. That is expressed to 3 decimal places, right? Then we divide by the 8.925. So let me do that. 0.021 divided by 8.925. Okay, so what I got is a long string of digits, 2.35, blah, blah, blah. But because we have 2 sig figs here, right? And we have 4 sig figs here, that means that this part here, whatever I get from that calculation, must be rounded off to 2 sig figs. So according to my calculation, this becomes 2.4 times 10 to the minus 3. All right? Minus 3. Okay? So that's what I got as a result of doing all that. But we're not finished yet because we have to multiply by the 100, right? And the 100 is in bold type. And remember we said that the numbers in bold type are exact numbers, right? So if I multiply this by 100, which is an exact number, times 100, I'm going to get 0.24. Remember, for exact numbers, it has an infinite number of sig figs, right? And this has 2 sig figs. So that means that this answer must also be expressed to 2 sig figs. All right? Any questions about this? Any questions? Any questions? Okay. How about C? How would you tackle C?
That's right.
I'm sorry?
That's right.
Okay, so you have to work out what's within the parentheses. Now, here's the thing. It's a combination of addition and subtraction, right? And the rules for addition and subtraction when it comes to rounding off is you round off according to the lowest number of what? Decimal places, right? So here we have 2 decimal places. Here we have 2 decimal places. Here we have 3 decimal places. And here we have 1 decimal place. So that means that whatever we get from doing this part here must be rounded off to 1 decimal place. So let's see what this gives. 9.04 minus 8.23 plus 21.954 plus 81.0. And when rounded off to 1 decimal place, I got 103.8. All right, that's what I got after adding them up and rounding off to 1 decimal place. Now, we're not finished yet because we have to divide by 3.1416, right? And you see it's in bold type. So that means that this is an exact number, while this is a measured or results from measured numbers, right? So that means that how many sig figs we need to round off the final answer to? No.
Oh.
Sig fig,
Four.
4 sig figs, exactly. So we're gonna take the 103.8 and divide it by the 3.1416. And according to my calculation, rounded off to 4 sig figs would be 33.04. And that's how you do that. All right? Any question about that one? Any questions? Any questions? Okay, the last one in this series is 9.2 times 100.65, and then all of that is divided by 8.31. Okay, now in this case here, it's a combination of multiplication and division, right? So unlike the previous examples where you'd have to work out this part in parentheses first and then round off, you don't have to do that in this case because it's a combination of operations where the rules will be the same. Now, key thing you need to note here is that the 9.2 here is in bold type, which means that it's an exact number. So basically, the number of sig figs that you need to round off your final answer to would be 4 because this is exact. This is expressed to 5 sig figs. And this is expressed to 4 sig figs. Right? And then we work it out. So 9.2 multiplied by 100.65 divided by 8.321. And you round off to 4 sig figs. So according to my calculation, this works out to be 111.3. And that's how you do that. All right. Any questions about this one? Okay. All right, so I take it I can clear this. And we scroll down to question number 4. And this is asking how many inches are there in 45.6 centimeters? And it gives you the information that there are 2.54 centimeters in 1 inch. And let me just say that this relationship is an exact relationship, the relationship between the inch unit and the centimeter unit, right? So we're going to start off with the 45.6 centimeters. And my question is, what will you put above and below in the conversion factor right here? What would go up top here and what would go below here?
1 inch.
1 inch will go up top and 2.54 centimeters will go below. Very good. So this cancels out with that. And we have to round out the answer to 3 sig figs. So that's 45.6 divided by 2.54. And according to my calculation, when rounded out to 3 sig figs, this becomes 18.0 inches. All right. Now the next question is asking how many centimeters are there in 1.23 times 10 to the minus 6 kilometers. So here we're going from kilometers to centimeters, right? And the way to go about doing that is to go from kilometers to meters first, and then from meters to centimeters, right? And basically, kilo means 1,000, so therefore 1,000 meters is equal to 1 kilometer. And centi means 100th, so therefore 100 centimeters is equal to 1 meter. So my question to you is, what would be the first conversion factor that you use here? To go from kilometers to meters.
It would be 1,000
1,000 what?
meters on top.
Okay, 1,000 meters above. And what goes below?
1
1 kilometer below. Oops, kilometer. Okay, so this goes with that, right? But we need another conversion factor which relates centimeter to meter. So what would go up top here? What would go below here?
1 meter.
1 meter,
Be 100.
1 meter up top
centimeters.
and 100 centimeters below. And
Wait, wouldn't it be 100 centimeters?
I'm sorry, it's the other way around, actually, yeah,
Oh, sorry,
yeah, my bad.
you're at the bottom.
It would be the other way around. Because you want to cancel the meter units, so it's going to be 1 meter below and 100 centimeters up top. So this goes with that. And the only unit remaining, which is what we're working towards, is the centimeter unit. So let's do the math, 1.23 times 10⁻⁶ times 1,000 times 100. So according to my calculation, this works out to be equal to 0.123 centimeters. And that's how that is done. Okay, any question about that one? Any question?
I do have a question.
Yes, ma'am.
So when we're testing, do we have to use dimensional amounts?
Yeah, I mean, like, if you're asked to convert from one to the other, yeah.
Like you wanna see us do it?
Yeah.
Oh.
Yep. That's how I know that you're doing, you know what you're doing. Okay, any other questions about it? Any other questions? All right, so let's. Do number 6. How many hours are there in 34.5 years? Now, let me hear your ideas about solving this one. How would you go about solving this one? They gave you the amount of years. They gave you 34.5 years. And they're asking for you to convert from that to hours.
Days.
Okay, so you're suggesting we go from years to days, right? I would agree. So how many days are in a year?
365.
365 days in 1 year. Okay, very good. What next?
Days to hours.
Days to hours. How many hours are in a day?
20.
24 hours in 1 day. And that's it. So years will cancel out, days will cancel out. So you're going to end up with 34.5 times 365 times 24. And you need to round this off to 3 sig figs. So when rounded off to 3 sig figs, I got 3.02 times 10 to the 5 hours. All right. Any question about that? Any questions? Questions? All right, how many inches are there in 355 millimeters? Let's hear some ideas. You're given 355 millimeters, right?
Go to meters.
Okay, so you could go to meters. There are 10 millimeters in 1 centimeter. You could do that. Millimeter units will cancel out. Then what?
How many centimeters are in the inch?
Exactly. Oh, by the way, I don't know if I told you this. Yes, I did tell you. The tables available in Canvas, you can look at that and that will give you all these relationships, right? So as she suggested, going from centimeters to inches, the relationship actually is 1 inch is equal to 2.54 centimeters. We saw that earlier, right?
Sorry, does that say 10 millimeters at the bottom? First?
Yeah, 10 millimeters,
Okay.
right. So the centimeter units will cancel out. So we need to do the number crunching here. 355 divided by 10 times 2.54. And according to my calculations, hold on, is this right? We'll do this again. 355 divided by 10 divided by 2.54. Okay, this is more like, okay. So round it off to 3 sig figs, that would be 14.0 inches. All right. Any question about this one? Any questions? Questions? All right. let me clear this.
I got one question.
Yes, sir.
Is this assignment one? Or is
Yeah,
this-
assignment one,
Okay.
right,
Is every week, are we gonna be doing assignments? in
Exactly,
class? Okay.
right, exactly. I like to do it this way so that, whatever problem that you may have, you can get my help in terms of,
Okay.
understanding. Okay, so number 8. How many milliliters, I'm sorry, is in a cubic meter? And it says here that 1,000 liters are in 1 cubic meter, all right? So basically, let me scroll down further. So basically, you're given 1 milliliter, right? And you're asked to determine how many meters cube or cubic meter is in 1 milliliter. So let me hear what you have to say about this one. How would you go about solving this one?
Liters.
Okay, so what would go up top and what would go below? In this
So-
conversion factor,
It would be 1,000
1,000,
milliliters,
okay,
1 liter.
1 liter above, very good. And then what would be the next conversion factor? In- in-
Cube.
Exactly, so
1,000
1 meter cube above. And 1,000 liters below. And when you work this out, this gives you 1 times 10 to the minus 6 meters cube. And that will be it. All right, any questions about this one? Any questions?
Sorry, what does it say up there, 10 to the? Oh, is it -6?
Yeah, 10 to the minus 6, yeah. Okay, any questions about this one? Any questions? Okay, the next one is how many miles are there in 3.44, oops. 44 times 10 to the 8 inches. All right, so they're asking for how many miles, and they also give you some additional information. It says here that there are 0.61 miles in 1 kilometer, all right? Now this one, you're definitely gonna need the tables for this one, because you need to figure out how to get from inches.
Could you go inches to feet and then feet to? So,
Well, let me check out the table here first. You could be right, but let me go to files. Well, let me go here. Let me go to the table. So this is the reason why the tables are provided, because you won't be able to, off the top of your head, know all the relationships between the different units. So. And of course, you'll have these tables to use during your test, so.
I did that and then multiply it by 1 foot over 12 inches.
All right, hold on, what is
It's
this? Hold on, hold on.
5,000 feet.
That's what I did.
Hold on. Let me scroll down to the appropriate page. Okay, you know what, let me clear this because, hard to see. Okay, so we're trying to go from, what is it,
Inches.
inches to
Miles.
miles. Okay, so let's see here. We have the relationship between inch and centimeters here, right? And we have the relationship between kilometers and miles here. But
We
there's,
also have feet.
what's that?
There's also feet.
And there's also the okay, yeah, hold on, you're right. And this underscores one important aspect of these conversions. There's more than one way of solving, right? So I think what she's mentioning is actually a shorter, let me see here. Yeah, because you can go from inches to feet and then feet to miles, right? So basically, you're given 3.44 times 10 to the 8 inches. So you can go from inches to feet. So you have 12 inches, 1 foot, right? So the inch units will cancel out, and then we can use this right here. Right? 1 mile above. And what was that? 5280 feet. Right? So the feet unit will cancel out, and you're gonna end up with your answer in miles. So 3.44 times 10 to the 8 divided by 12 times, or not times, divided by 5280. And we have to round this off to 3 sig figs. So that would be equal to 5.43 times 10 to the 3. And the units, of course, would be miles. And that's how you do that. All right, so yes, there are more than one way of doing conversions from one unit to the next. Very often you find that to be the case. I try to find the shortest route. All right. Okay,
That's not the,
that's not the answer. You sure? Let me do this again.
no, I'm not sure.
3.4 times 10 to the 8 divided by 12 divided by 5, is it 5280, right?
Yeah.
Okay, divided by
That's the same answer.
5280. I got 5,429.292929, which rounds off to 5.43 times 10 to the 3.
What?
When you round off to 3 sig figs.
Oh, I know what I mean.
5.43 times 10 to the 3. All right. Any questions about this one? Any other question? What did I get what? Oh, that's the relationship between the foot unit and the inch unit. 12 inches equal to 1 foot. 3 feet is equal to a yard. And beyond that, I don't know anything else. But those I know. Often. Okay, any other questions? Any other questions? Any other questions? All right, so let me clear this and then move on to the next question. This one is interesting. So this question is saying that you have a waterbed that is filled with water and it gives the dimensions, right? 8 by 7 by 0.75 feet. And then it says taking the density of water to be 1.00 grams per cm cube, determine the number of kilograms of water needed to fill the waterbed. All right. Now, the hint in this question is what? Density, right? And what's the formula for calculating the density?
Density.
Density is equal to mass over volume, correct? Now, what the question is asking for is the mass. So we have to rearrange this equation to get mass. So mass will be equal to what? Based on the equation. Based on the first equation.
Kilograms.
No, what would be the mass? What would be the expression, I should say, for mass?
Density times volume.
Density times volume,
I
exactly, right.
understand.
So basically, we have to multiply the density 1.00 grams per cm cube by the volume. Now, the volume is given by the product of all these here, right? So that would be 8.0 times 7.0 times 0.75 feet cube. I'm going to put these in parentheses here, and I'm going to put feet cube outside, right? Now, here's the problem. The problem is that this will not give you directly, this combination I have here, will not give you directly the answer in the kilogram unit, which is required. Not only that, but we have a unit of volume here expressed as feet cube, and down here we have centimeters cube, right? So we need to do some conversions. I will do the simplest one first, and that is convert the grams to kilograms. So what I'll do is multiply by a conversion factor, which allows us to convert the gram unit to kilogram. So that will mean that I would have 1,000 grams here and 1 kilogram above, right? So this unit will cancel out with that unit. But now we have to do some conversion of feet cube to centimeters cube, right? Now going back to the, well, we know that there are 12 inches in 1 foot, right? So I would put 1 foot down here and 12 inches above, right? However, because we have a cube here, we have to cube everything here so that the feet cube would cancel out with the feet cube here, right? So the unit that we're going to be left with here would be inches cubed. and we have to convert that to centimeters cube, and you're gonna see the reason why shortly. So we know that 1 inch is equal, 1 inch is equal to 2.54 centimeters. Centimeters, and because we have inch cube here, we have to cube all of this right here. So that this inch cube unit will cancel out with this inch cube unit, right? And then this centimeters cube unit will cancel out this centimeters cube unit. Right? So the only unit that you're going to be left with would be the kilogram unit. All right, so let's do this number crunching here. So we have 1 times 8 times 7 times 0.75 divided by 1000 times 1/2 cubed times 2.54 cubed. And according to my calculation, now this, let's see here, how many sig figs do we need to round this off? 2 sig figs, because we have 3 here, we have 2 here. That's exact, that's exact, that's exact. So therefore, when rounded off to 2 sig figs, I got 1.2 times 10 to the 3 kilograms. All right? Any questions about this? You look puzzled.
So all the cubes cancel out, so you don't have to
Yes.
cube anything.
Well, we have to cube this conversion factor here. We have to cube this one right here.
But not really,
What do you mean?
like you actually cubed it,
Yeah, exactly.
so you did 12 times 12 times 12.
Right, exactly. If you notice, I said 12 cube, I actually put that in the calculator,
I understand.
and then 2.54 cube, and that gives you those values cubed. And I'm glad you raised that issue, because one common error students tend to make in these type of problems is that they forget to cube. Right, they just multiply everything and get the wrong answer, all right? Okay, any other question about this one? Any other questions? Any other questions? Any other questions? Okay, so that brings us now to question number 9. Is it okay for me to clear this? Oops. Let's go down. Okay, so number 9. Oh, that's the last one. Okay, that's the last question, all right. So number 9 talks about an oil slick, right? Oil spreads on water and it forms a film, and the thickness of the film is given right here. Right? And the question is asking how many square kilometers, of ocean will be covered by the slick form when 2 barrels of oil are spilled, and it gives you that relationship here. 1 barrel is equal to 31.5 gallons. And again, you're definitely going to need a table for this one. But anyway, so I don't know if you should have met this in your previous math experience. The relationship between the volume, area, and thickness of an object. Does this look any way familiar to you? Volume is equal to area times thickness. All right. What the question is asking for is the area, right? So the area will be equal to the volume divided by the thickness. Now the volume is equal to 2 barrels. I'm going to use 2 BL. BL is the unit for barrel. All right. Divided by the thickness, which is 120 nanometers, right? So the question is asking for the area in kilometers squared, right? So the strategy I would take is that I would try to convert the barrels to kilometers cubed units and the nanometers to kilometers, right?
Sorry, what does that say at the top, the second, the 120?
Nanometer thick.
Oh, sorry, above it, the numerator, the second fraction, 2 pounds.
Oh, I'm just using this for barrels.
Okay.
BL, I'm sorry,
Alright,
right. That's just my unit I'm adopting for barrels, right? Now, the reason why I'm taking this strategy is because the question is asking for the answer in kilometers squared, not cube, right?
Yes.
So therefore, if we get the answers or the values for these here, in these units, then this kilometer unit will cancel out one of these and you're gonna be left with kilometers squared. Right? So what we have to do now is, I'm going to rewrite this here. Area is equal to 2 barrels, BL, divided by 120 nanometer. And what I'm gonna do is focus on converting 2 barrels, to kilometers cubed. All right, so how am I gonna do that? Well, they gave us this relationship here, so I'm going to multiply that by 1 barrel below, divided by, well, up top, I'm gonna put 31.5 gallons. 31.5 gallons. All right, so that's the first step. Now, the next step is to go from gallons to kilometers cubed. Now, let's see what values from the tables we can use. Okay, so down here,
You didn't go from gallons to liters and then liters to.
okay, so down here, we can, okay, like she said, we can go from gallons to liters. So let me multiply this by. Okay, what's the relationship? 1 gallon down here. And 3.7854 liters above, all right? And what next? Now, here we have, okay, what do we have here? We have 1 liter here being equal to 10 to the minus 3 meters cubed. So I'm gonna put 1 liter below and 10 to the minus 3 meters cubed, right? And then now, the relationship between meters cubed and kilometers cubed is that you have 1,000 meters equals to 1 kilometers, but we have to cube that. And that's as far as converting, let me see here, so the barrels will cancel out, the gallons will cancel out, the liters will cancel out, and the meters cube will cancel out. So up to this point, you'll be left with kilometers cubed. Now, the next thing we have to do now is convert the nanometers to kilometers. Now, nano means 10 to the minus 9. So here, I'm gonna put 1 nanometer above and 10 to the minus 9, meters below, right? And then I'm going to convert from meters to kilometers. So 1 kilometer is equal to 1,000 meters. So I'm going to put 1,000 meters above and 1 kilometer below, so that this nanometer unit will cancel with this nanometer unit. This meter unit will cancel with that meter unit. And importantly, this kilometer unit will cancel out one of these 3 kilometer units. So basically, this will be converted to 2. Well, actually, let me not do that, because that would be a serious error when I start doing the multiplication. Let me just leave this as it is. Cube. And then we have 1 kilometer here. And then we have to do the number crunching. So let me do that now. Let me go back to the assignment.
Sorry, I'm having trouble seeing the.
Oh, sorry.
Do we not also have to cube the one at the end, because the 1 kilometer over 1,000?
No, because we're starting from here. Okay, let me explain this. We're trying to convert the nanometers to kilometers, right? So it's not like this was cubed. If this was cubed, then yes, we'd have to cube this and we'd have to cube that, but this is not cubed. This is straight nanometer units. So what I did was convert from nanometers to meters. This should be 10 to the minus 9. I'm sorry for the lack of clarity here. This should be 10 to the minus 9. It's kind of hard sometimes writing on this thing. Right, so the purpose of this is to convert the nanometers to meters, and then the purpose of this conversion factor is to convert from meters to kilometers. So we don't need to cube that. We did need to cube, like for example, because this is meters cube, and we're trying to convert to kilometers cube, we had to cube this here, so that this meters cube unit cancels out with that meters cube unit.
But it's outside of the parentheses, does it not affect both the numerator and the denominator?
You're talking about this? Yeah, it's going to affect both. You're talking about these two numbers? Yes. It's going to affect those numbers. In fact, let me do this right now. So, how am I going to do this? Okay, let me do 2 divided by 120 times 31.5 times 3.7854 times 10 to the minus 3, and then we get to divided by 1000 cubed, and then we divide by 10 to the minus 9, and then we multiply by 1000, and the answer I got is, and in this case, okay, how many sig figs do I need to round this up? Round off to 2 sig figs because of the 120 here. The 2 barrels, I would consider that to be an exact number. So let me see here. So the answer I got is 1.4 times 10 to the 3. All right. And the units, of course, would be kilometers squared. Let me do that again. I have a sneaking suspicion that we have. Two divided by 120 times 31.5 times 3.784 times 1.713 divided by 1000 cubed divided by 1.7 times 1000. Okay, I got something different. I knew I did something wrong. This should be 2 kilometers squared. Okay, so the answer is actually 2.0 kilometers squared. So let me correct that. Two point zero kilometers squared. All right. So that's it squared. So that's it for today, folks. What I'm going to do right now is I don't have that, so let me just get this here.
What was the answer to?
2.0 kilometers squared. So let me open up a Dropbox for this assignment so that you can turn it in. I've posted an announcement concerning, the things you need to do to submit your assignment. So let me today is the 20th. Okay, so let me okay, so I'm going to set a deadline date of the 22nd at midnight for you to submit that assignment. Let me just do some other things here. So the due date is going to be 22nd, and this will be available from now. Until 22nd. Okay. Okay, you save it. All right, so make sure you submit it, make sure you follow all the instructions that I gave you in the announcements concerning how to submit the assignments, make sure that it's submitted in a PDF document, make sure you do the ink and all that good stuff, all right? Okay, so that's it for today, folks. I'll see you guys. Oh, and let me also publish the videos for next week. I'm going to make an announcement about that later on, so.
And I just have one quick question,
Yes, sir.
just about that last. Question, I was just wondering because we squared the meters here to cancel out, but
Well,
then we didn't, I'm sorry, cube, sorry,
Right.
cube, but then we didn't cube
Right.
this to cancel with the kilometers.
right, and that's because for the last two conversion factors, we were concerned with
Oh, okay,
converting the nanometers to kilometers.
oh, I see,
So
okay,
because that is not squared or anything, we don't. do
oh,
that.
okay, thank you.
Yeah. Okay, so chapter 2 is now available. So make sure you watch those videos, folks. Chapter 2. Yeah, you can come in.